These are the solutions to homework number 2. So let's go through them, starting with exercise number 1. So this is where basically you have to print out the sizes of each fundamental data type, but obviously not typing out the values yourself, but having the machine calculate them. So let's go ahead and see that in action. And let me take you to the editor so you can see. So here we are. We've got the IO stream at the beginning, just our preprocessor because we're going to be dealing with output, our namespace, and then our main function. And really the only bit that's new here is that when we're printing out the name, we're printing out beside it the actual maximum memory size for that fundamental type. So we're doing that using the size of function. And to use it, we just got to put in the name of the type inside, and then it's going to print out, it's going to return that value that we need. So the size of that data type in bytes. So let's go and run it and just make sure that works. And there you go, exactly as expected. So you get char1, char2, int4, and so on and so forth. So let's go back then and look at exercise number 2. So for exercise number 2, you had to print out a special text sequence using a bunch of special characters and laying it out in a very specific way. And the only way you could get around and actually make it happen is if you were using escape sequences. As you can see here, we've got a ton in the solution. So let me show you what that's going to look like once we run it. So we have here our main function, and we start out with cout, and then our extraction, our insertion operator. And notice how we are only using one cout object. So that's something that we can certainly do. We, we can we can borrow that same one rather than have to keep repeating it altogether. And we start with the first line of the string, right? And we're having 2 line breaks by using the \n, and then we have a tab, push it over. Then we have here again on the next one, 2 line breaks, 2 tabs, so pushing it over a bit further. Some quotation marks that have, you can see here the escape symbol for the quotation marks, backslash quotation mark. Then we have the same, but an additional tab. And here we're actually escaping the backslash. So we're having a backslash in there. And then for the forward slash, we don't need to do anything because it can be it gets automatically included. We don't need to use an escape sequence at all whatsoever. So let's run that and see what the output is like. Okay, and there we are. So as you can see, we did all that with just one cout object and a lot of escape sequences. Now we move on to exercise 3. And for exercise 3, you had to specify which variables were initialized incorrectly or which constants. So the first one here that we have is int a 2.5. The problem being 2.5 is not an integer value. The next one here, this constant, we actually haven't initialized it at all. We've just declared it without giving it any sort of value, which it's kind of pointless at this point. The next one being char said, and then we're putting in 500. Obviously, the value for 500 is way too large to fit in it into a single character. The int big equals 40,000. That goes over the maximum of 32,767 on a 16-bit system. So we have to be mindful of that. That depends on the system that you're using. Then double, and then we name it piece. So in this one here, we cannot use this symbol in the variable name essentially. So it's it has to be alphanumeric. And then finally, for the float value, the accuracy can only be 6 digits. So moving on to exercise number 4. This one's all about defining and initializing variables. So we have to define doubles, add them up, and then get the difference. So let's go ahead and see what that looks like in the actual development environment. Okay, so here we are. And we start out defining our floating point variables. So the first one, as we needed it to be, the second one, y, and then we can actually create a variable to store the result of the sum. So it can be x plus y, and that's going to store the sum of that. And then when we go to print it out, we can actually use that sum variable to display the result. Another thing we can do is actually, for example, when we're doing the difference and we're subtracting them, we can just put in parentheses the actual calculation, and it will actually complete the calculation within this bit and then just return the value, and it'll get printed right away. So as you can see, if you had to display this difference multiple times, you would have to repeat that calculation, whereas you can just define it once. Example, x minus y, and then you can just print it out like that. So that's another way that you can do it if you wanted to, just a slight variation. But let's go to the original and let's print it out to see what that looks like. Okay, there you go.